We're going to continue with utilizing one of our smart machine kits. We're going to enter manufacturing. Often you will use the file new approach. In this case, I'm going to just start manufacturing directly into this part. And the template that I use is not really too important for the initialization, as you'll see in a moment. So this just simply initializes our part for manufacturing. I'm going to, I'm on my machine tool view. So let's go ahead and utilize that smart machine kit. We can just double click and retrieve it from the library. If we just hit OK, we'll see all the kits or all the machines. We'll grab the one from the bottom. In this case, I'm going to use the simpler of the two methods for mounting the part. I happen to know I modeled this part with a 0, 0 at the base. You could certainly move this. And I'm just going to go ahead and hit OK. And this should bring in the machine mounted to that location. And I think that looks pretty good. Now I'm going to turn off some of the geometry of the machine. I'd like to be able to see inside. The door is kind of in the way, so we'll hide that. In your machine tool navigator, you want to make sure that your part is specified. So in the part, just double click that and make sure that that is selected as the part. And if you had blank and fixtures, you could also select those. In this case, I'm going to use a bounding cylinder. So okay, so I've gone ahead and copied and pasted the geometry that we need here. Let's take a look at what we have here. We have a main at the top, and you can see the purpose is main, fixture offset is 0. Underneath this we have our workpiece object, and we typically would have a part defined as we do, and a blank defined, and you could, in this case we've used bounding cylinder, and that actually gives us a cylinder here, right directly in the geometry view. And then underneath this we have our G54, which is our first fixture offset, and we really just want that to be at that top. It's set to fixture offset, purpose is local, and 1 will use the first in the series of available fixture offsets depending on what your post is outputting. We'll get to the operations later. And then G55, in this case I've added a little pocket to the side. So in this case with the Siemens control, and you can see this by referencing the Sim08 delivered machine kit. It's a cinematic based kit, and there are some best practices that would be described in the documentation. So in this case I'm going to do possibly some hole drillings and this, or hole milling. So we want to be able to use canned cycles and so forth at this tilted plane. So we need to have a work offset and a rotation. So the G55 here, you can see it's still set to local, fixture offset, and 2. And we'll set that to here, and I want the Z to be along that cylindrical axis, and I want the X to be lined up here, and that looks pretty good. So we'll just hit OK. And then the rod underneath it, we need to have that in place and just specified as CSYS rotation and that should give us the results that we want. So again, examine Sim 08, examine the geometry structure there. So let's, this contour profile, again, I copied and pasted this in from previous. We just need to select this wall. It's already been selected. And I've simply modified the non-cutting move so it's a very simple engage, so we can have very clean code in the output. And if we generate that, we should get a toolpath, and it all looks good. And the same with the floor and wall. I've just simply selected that face and the whole. It looks like maybe I'll regenerate this. Looks good. May need to reselect the whole. Now it looks good. I'm just going to run with the defaults and generate that and hit OK. So far so good. I believe we have a good geometry structure. If we go to our machine tool navigator and we preview the motion, show the machine position, we should see the part. The part should move intact with the rotary, and of course all the other axes, I'm sure, work just fine. So that all looks good. And come back to our Operation Navigator tab. I like to switch to my program order view. Make sure everything is nestled under the proper parents, and I'm going to select the top program and we're going to simulate the machine. And I'm just going to go ahead and play. I have tool trace turned on so that I can see the path that the tool is taken. And then we do our facing and our hole milling. So there's actually two solutions to cutting this face and the pocket. You could rotate the C 180 degrees and the A the opposite angle. So sometimes the machine will give you the right solution. It really takes it chooses on its own internally based on the kinematic model in the post. So if we want to specify it, or if we want to limit the rotation in a certain, I'm going to switch to our geometry view. So because these two operations are both underneath this geometry, I've gone ahead and created a UDE, user-defined event, and I've placed it on this geometry parent so that any operation that is underneath that will naturally inherit that. And what I've used is called the preferred solution, and it's placed in the start event. So I'm asking for C to be solved preferably within a 0 to a 180 degree range. And that's why it cut near the front of the part. And if I make this inactive, or if I just simply remove it and then go back here and simulate the machine again, it's going to post it all again in the background and resolve it. And then if we go ahead and play again, this is all the same. We'll come back to this, what's going on in the G code with this circular motion, and you can see now it's cutting on the other side of the part. I mean, you know, it's possible that the feature is kind of obscured from the operator's view, and it's a little nicer if the operator can actually see the cutting motion, maybe to see if the tool broke, or see if the coolant is placed correctly, or what have you. So those are some reasons you may want to cut with different alternate solutions with a multi-axis machine. So let's reset this and look at the code. I'm going to switch to execution view, and this is a Siemens 840D. Now we have we're going to tilt that taper in the top is a 15-degree taper. So we're going to tilt it using cycle 800. But we're actually, the key here is that we're using Traore. So this is a transformation of the coordinate system, so the code becomes a little deceiving, because once you enter Traore, you've entered into a different realm, a different coordinate space. So the machine is operating in a different coordinate system. So when it's interpreting this G code, it's almost as if it's the machine is kind of rotated around. We've rotated twice. We definitely need Traore once for the A axis, but it also applies it additionally when it rotates the C axis. So it gives you some very surprising code in this case, but it certainly does work. And so if you can imagine that, as far as the machine knows, its coordinate space is being, has been rotated, or it's being rotated constantly as it rotates this axis, and then after that it will leave that coordinate space. So I think that's a good place to stop.